So today I am going to discuss elastic collision between two particles in laboratory frame of reference. In the earlier lecture I talked about elastic collision, but that is the one-dimensional in the center of mass frame and laboratory frame of reference, right? So consider a particle situated here, and let m1 be its mass, and it is moving along x-axis, say with velocity u1, and let us assume that there is another particle m2, and I assumed that this m2 will be at rest. That's what I have assumed. But when these particles will collide with each other, it is the direction of motion of the incident particle before collision. But after collision, this first particle having mass m1, it starts moving towards this direction after collision. Say it is m1 and it starts moving with the velocity v1, and similarly second particle means the particle which is at rest, it starts moving with velocity v2 along this direction, and say this incident particle making an angle theta 1 with the direction of motion of the incident particle before collision, and this recoiled or scattered particle means second particle which is at rest, it is making an angle theta 2 with this direction. Now theta 1 is known as angle of scattering, and theta 2 is known as recoil angle. Let us define these angles as it is the angle between initial direction and final direction of incident particle. And this final direction, we are talking about this after collision. And this initial direction is before collision. So that means this particle is moving along this direction. Before collision, it is the direction initial, and when it collides with this particle, it starts moving along this direction. So this angle is basically, this is known as angle of scattering. Similarly, let us talk about recoil angle. It is the angle between direction of target particle and initial direction of incident particle. Direction of incident particle. So it is the direction of incident particle and it is the direction of the target, because this is the target particle and it is its direction after collision, right? So this angle is known as recoil angle. Now collision is elastic. Collision is elastic, and if I resolve the forces, because what will happen after collision, one particle starts moving along this direction with velocity v1, m1 particle, and m2 particle, it starts moving along this direction. with velocity v2, and if I resolve these velocities, then this is one component which we are getting, and these are the two different components, right? So there is, yes, this is v1 and v2, this is v1 and this is v2. So let me call this as it is v2 cos of theta 2, because this angle is theta 2 and this angle is theta 1, so it is v2 sine of theta 2. Similarly, this is v1 cos of theta 2 and this is v1 sine of theta 1. Sorry, it is theta 1 because this angle is theta 1, so it is the component along y-axis. So according to law of conservation of momentum, conservation of momentum means it's a linear momentum and it must be conserved. So that means momentum before collision must be equal to momentum after collision in that direction. So I am taking first of all momentum along x direction. So that means this is for x direction, and m1 u1 plus, because second particle is at rest, so that's why it is this. So it is m1 v1 cos of theta 1 plus m2 v2 cos of theta 2. And similarly, I can say that because along this direction initial, because particle is not moving along y-axis initially before collision, so their initial momentum will be 0, but it is m1 v1 sine of theta 1 minus m2 v2 sine of theta 2, because they are, this is along positive y-axis and this is along negative y-axis. That's why I'm taking here negative sign. And let me sum up these two results. So if I sum up these two results, so that means the equation which I'm getting, m1 v1 cos of theta 1 m2 v2 cos of theta 2, it must be equal to m1 u1, and let me call this as equation number 1, and m1 v1, from this equation I can write down m1 v1 sine theta 1 minus m2 v2 sine of theta 2 is equal to 0. Let us call it as equation number 2. Also kinetic energy is conserved. So kinetic energy is also conserved. So therefore, keeping this in mind, I can write down half m1 u1 square plus 0, because the kinetic energy of second particle will be 0 because that is at rest. It is m1 v1 square plus half m2 v2 square. So it means I can write down it as 1 by 2 m1 u1 square is equal to 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. So let me call this as equation number 3. Now our purpose is to calculate now v1, v2 and theta 2. So let us assume that theta 1 is known to us and particles are of same mass. This means that both the particles are of same mass. If I do this, then it's a case which we have assumed. So if I do this, then equation 1, 2 and 3 will become, because particles are of same mass, then the mass value will be cancelled out. So therefore, equation number 1 will become, it is v1 cos of theta 1 plus v2 cos of theta 2 is equal to u1, and another equation v1 sin theta 1 minus v2 sine of theta 2 must be equal to 0. Let me call it as equation number 4. This is 5. And similarly, v1 square plus v2 square is equal to u1 square. Let us call it as equation number 6. So if I use this equation, using this equation I can write down u1 minus v1 cos of theta 1 is equal to v2 cos theta 2, and from here I can write down that v1 sine of theta 1 is equal to v2 sine of theta 2. Let me call it as equation number 7, this as equation number 8, and from here I can write down that u1 square minus v1 square is equal to v2 square. Let us call this as equation number 1. So now squaring and adding 7 and 8, that means I will apply the operation now, that this 7 square plus 8 square, it gives me, this is the 7, so taking it square, so it is u1 plus v1 cos of theta 1 its square plus v1 sine of theta 1 its square must be equal to v2 cos of theta 2 its square and plus v2 sine of theta 2 its square. So this can be simplified as, this is u1 square plus v1 square cos square theta 1, sorry, it is minus, so let me do one thing, yeah, it is minus so it is a square plus b square minus 2ab, so it is 2 into u1 v1 cos of theta 1 plus v1 square sine square theta 1 is equal to v2 square cos square theta 2 plus v2 square sine square theta 2. So it means I can club these two terms together and these two together. So it can be written as u1 square plus v1 square. From here I can take cos square theta 1 common, and here I can take sine square theta 1 common, and this term will remain as it is. So minus u1 v1 cos of theta 1 is equal to v2 square cos square theta 2 plus sine square theta 2. So its value is 1, its value is also 1, because sine square theta plus cos square theta is 1. So that means I am getting u1 square plus v1 square minus 2u1 v1 cos of theta 1 is equal to v2 square, but as I know that v2 square is equal to u1 square minus v1 square using equation 7, so if I use that value, using equation 6, right, if I use this here, then this equation will become u1 square plus v1 square minus 2u1 v1 cos of theta 1 is equal to u1 square minus v1 square. This u1 will cancel out with it because both are equal and lying on opposite sides. So from here and bringing this towards this side and this towards that side, so it is 2v1 square is equal to 2u1 v1 cos of theta 1. This will cancel out with it, means, and 2 will cancel out with it. So v1 comes out to be u1 cos of theta 1. That's what we are getting, right? Let me call this as equation number 10. Now substituting V1 is equal to U1 cos of theta 1 from equation 10 in equation 9, and 9 equation is U1 square minus V1 square is equal to V2 square. So if I put its value here, so I am getting that U1 square minus U1 cos of theta 1 its square is equal to V2 square. So it is U1 square minus U1 square cos square theta 1 is equal to V2 square. But it can be taken outside, so it is 1 minus cos square theta 1 is equal to V2 square, and its value will be sin square theta 1. So that means I can write down U1 square sin square theta 1 is equal to V2 square. Taking square root on both sides, U1 sin theta 1 is equal to V2. Thus I can write down V2 is equal to U1 sin of theta 1. Let me call this as equation number 11. Let us sum up these two results now. In the equation 10 which I got is that V1 is equal to U1 cos of theta 1 and V2 is equal to U1 sin of theta 1. That's what I got, right? This is equation number 10 and this is equation number 11. Now our purpose is to calculate theta 2. Right, so if I do this operation 8 upon 7, then this leads to V1 sin of theta 1 upon U1 minus V1 cos of theta 1 is equal to V2 sin theta 2 over V2 cos of theta 2. This will cancel out. So it is tangent theta 2. So that means this tangent theta 2 is equal to, it is U1, sorry, yeah, it is U1, sorry, no, not U1, but it is V1. But if in place of V1 I will put its value, so it will become U1 cos of theta 1 into sin of theta 1 as it is, divided by U1 taken outside 1 minus, sorry, not common, but it is U1 minus U1 cos of theta 1 and cos of theta 1, right? That's what I am getting. So taking U1, it is cos of theta 1 sin of theta 1 divided by U1 can be taken outside, so 1 minus cos square theta 1. It is cos square theta 1. Now this can be written as U1 will cancel out with this U1, and this cos of theta 1 cos of into this sin of theta 1 divided by 1 minus cos square theta is sin square theta. So this will cancel out with it. So it means it is cos of theta 1 over sin of theta 1. Right, that's what we are getting. Therefore, tangent theta 2 can be written as cot of, because cos over sin is cot, so cot theta 1. Let us convert into 10. So if I convert this into 10, then it will become pi by 2 minus theta. That means theta 2 is equal to pi by 2 minus theta. It means theta 1 plus theta 2 is equal to pi by 2. So here we have considered that both the particles of same mass, so if two particles of same mass will collide with each other and target particle will be at rest, then in the laboratory frame of reference, the angle between or the sum of incident and the scattering particle will be scattering angle and the recoil angle, their sum will be equal to 90 degree or perpendicular to each other. So it means, what does it indicate? This indicates that if incident particle collide with a target particle at rest, and both the particles are of same mass, then both the particles move in perpendicular direction to each other after collision. So that's what we are getting out of it, right? So that's all for this lecture. And then in the next lecture, I will talk about in the next lecture, I will talk about elastic collision, but in the center of mass frame.